record button. So we gave you a bit of code. We have the characters Phoebe, Rachel, Joey, and we printed some stuff out. Let's see here. Gus, what do you think? What are your original thoughts?
Well, I mean, just given that like if you have 3 items in your array, like it doesn't take that much code to print them all out. But if you had 30, that would be an awful.
Yeah, totally, right? The idea here is that this doesn't scale, right? Like for, when we're just dealing with Phoebe, Rachel, and Joey, like, yeah, puts 0, puts 1, puts 2, that's fine. But we can startly, think about situations where something like this can go sideways, right? How many things do we think they sell on Amazon? Like a lot. More than probably our minds can wrap our heads around. And like, do you think that you'd want to be the developer in charge of printing out a report or everything if you have to do puts item bracket 1, 0, 1, 2, whatever? Like that is a terrible idea. And so what we have here, like with this, using the put statement like so, is that we have a solution that works for a small number of items but doesn't work for a large number of items. The term we use for this is that we say that this does not scale. Right? As the number of items in our collection gets larger and larger, the amount of work also kind of grows with it, right? We want to make solutions for problems that are what we call dynamic. And when we use the word dynamic, it means like the same bit of code will work fine, considering like if we have just these 3 characters, or it'll work if we have however many things they sell on Amazon. And so we're going to use the term collection. And a collection in Ruby, like when I say collection, it's like capital C collection. We're talking about specifically, we're talking about a data structure that holds multiple items. And in Ruby, that refers to either an array or a hash. Today, we're going to be focusing on arrays. The next term we want to talk about is doing something several times. And when we do something several times, the word we want to use is iterating. And so the method we're going to talk about today, each, is a method that is going to iterate over a collection. What this means is that for how many things we have in a collection, it is going to do something for that, do something for everything in that collection. An iteration is like one single pass over an element. So let me put some code on my screen. Like this. Can you see this? Is this large enough for everyone? Is it not large enough for anyone? I'm okay with making it bigger. That's fine. Cool. So what's happening here is that the very first thing we're doing here is that we are creating a collection. We have this array of Phoebe, Rachel, and Joey. And those are strings.
Sorry to interrupt. It looks like Alex wants it bigger.
Sure. Oops, that's the other direction. Cool, is that cool? Yeah, if it's not bigger for you, just like feel free to unmute yourself and just let me know. That's the easiest way because it is a lot of faces on my screen. So where was I? Yeah. So we have this collection here. Characters is just an array of 3 strings. And .each is a method that we call on this characters collection, this characters array. And everything we do, everything between this do and the end is what we refer to the block. The block is what runs for each element in the array. So because we have 3 things in this array, it's going to run 3 times. If we had 0 things, well, if it had 0 things in it, it would run 0 times. I'm pretty sure. Yeah, I've actually never run on 0 things. I feel it will run 0 times. That makes sense. If we had 5 things in this array, it would run 5 times. If we had a gazillion things in this array, it would run a gazillion times. And so character singular, what's within these pipe characters, the pipe is the key, it's above your enter key. It's called a pipe. What is in between there is known as the block variable. For each iteration, this variable holds the current element that we're iterating over. So we've already said that this bit of code between the do and the end will run once for every single thing we have in the collection. The variable inside the pipes will take the value of whatever thing we're iterating over. So because there are 3 items, character will take on each one of these things that's in the collection. So first example, so how this is going to work is that the first time through, character will equal Phoebe because that's the first one. And it's going to print out Phoebe to the screen. It's going to go back again because it has 2. We have the second one. And so the second time through, character is now going to equal Rachel, and it's going to print out Rachel to the screen. And it goes back again. On the third time through, character is equal to Joey, and it's going to print out Joey to the screen. And then it's going to quit because there are only 3 things in there. It's going to run 3 times. It's going to run what's in the block being what's between the do and the end, 1 time for every single time, every iteration it goes through. So I'm going to run, you got to save it first. Oh, gosh, see, yeah, that's the button to save. Ruby each.rb, and we can see here that it printed out each of these things to the screen. And you're like, yeah, I mean, we didn't save any code here, but you know, we can see like, what if we did Chandler? Ross? Is there another Friends person I'm not thinking about?
I mean, if you want to put Gunter
Monica.
or people like that.
There's only 6 of them, right? I'm not missing anyone, am I? No, I think there's only 6 of them. Cool. So we are going to run this again. And we see here that it's printed out the 6 names with the same 3 lines of code. This is what we mean by dynamic. In that the same bit of code works whether we have 1 friend, 2 friends, 3 friends, 5 friends, 6 friends. If I had the time, I would go pull the character names of every single person ever appear in the Friends. Can't call it a cinematic universe, but the Friends television universe. We put it in here, and this same 3 lines of code would print out for everyone. I did see a hand that is now gone. Does that question still exist?
I was going to ask what the naming convention was for the block variable,
Yeah,
but
yeah.
I figured it out where,
Mhm.
you know, you have characters, which is going
Yeah.
to be
Mhm.
your array, and then it's just the singular version of that because you're going to be
Yeah.
pulling out each one through each iteration.
And that's totally, and the thing is, I also want to demonstrate, like, it does not matter what we name these things. This, like, the Ruby is not smart enough to understand that character is the singular of characters. So I could change this to, what do I want to change it to? Nope, no, that is not how you spell pizza. Pizza. And if I change this to pizza, that still works, right? What we call this is absolutely arbitrary. The standard Ruby convention is that we should call collections a plural word that describes what's inside it, and the block variable is going to be a one thing, a single thing. That is generally what you're going to do. I'm sure during the course of your career, you're going to find like some weird case that requires you to name it something weird, and like that's fine. You can do that. We could just be like, we could, you know, you could get all weird, like slice. We call that. Oop, no, slice, and we call this slice, and this is going to be pie. Like, this makes absolutely no sense because you get their slices in a pie, but it'll still work because Ruby doesn't care what you do. Ooh, no, wait. Oh, my mistake. We'll call this pie. Right? That still works, even though, like, logically, no, like, they're slices in a pie, not pie and slices. Right? Like, Ruby doesn't care what you do. Ruby just, as long as you're consistent, right? And that's what this does. Let me put this back to characters. Yeah. All right. So in general, oh, sorry, Gus.
Yeah, if you name variables like slice, like something that is the name of like a Ruby method, are you running the risk of like confusing it, or can it figure
Yeah.
out just from context? what you're
It's
doing?
going to do that. We're going to cover that when we start talking about scope a little more. In general, you want to avoid naming things that share names with things that are already reserved in Ruby.
Okay, thank you.
Dun, dun, dun. Oh, wrong box. Here we go. So in general, the format for using each looks like this. Collection.each do. Oh, this is embarrassing. I don't know where the pipe button is on my keyboard. Oh, there it is. And in here, we just have whatever. Run. End. And so this is the general kind of format of .each. There is a single line. There is a single line variant, but we prefer that you use the do end syntax. It is going to be a lot simpler to keep to that. At this point, the last thing I want to mention is that each returns the original collection. Right, and so like be aware that it returns the original collection. We're going to talk about how we can transform collections and whatnot, but right now, be aware that each returns the original collection. Cool. Any questions at this point about just using each? Fair, no. Okay, cool. Fairly straightforward so far. I'm
I
going to
had
go
one.
ahead. Oh, sorry.
Could you give an example of like when that might be problematic?
Yeah, when you, it's just something to be aware of when you are running a method has each inside of it. I think that as we go through, we're going to see more examples of this. So
Cool.
let's put a pin in that. And I think that like just knowing this, it's like you're just pronouncing the stuff to the screen. It's not very clear. But as we get to start doing more complicated things, it's something you got to be aware of. Liam?
So sorry, just to clarify.
No apologies here. You don't apologize when you ask questions. You just ask it.
The block variable and the block character puts character, those two have to be the same if that's what you want them to do, but not the characters dot each and the puts character.
Yeah, so the block variable is that like this is how we access whatever we're currently iterating over.
Okay.
Right, because like if when here we don't have access to like the thing, we're trying to do one thing per each, and the block variable takes the form of whatever
that's
we are
the one
on.
thing that you're doing for that run.
Yep.
Okay.
For that thing, right? And that'll change with every as you kind of go along the list, right? And we'll kind of take a look at that in just a moment.
All right. Cool.
Cool. All right. So, so my dog has squeaky toys, and she's not allowed to play with them while I'm teaching, and they are on my desk, and she's currently staring at them because she wants them, and it's very cute. But no, she's not going to squeak while I'm teaching. All right, so what we're going to do is we're going to have a collection, and I'm just going to copy and paste some more code here. Cool. Oh, this is old. Let me update this. So what do we think we're going to get? Let's take a minute to look at this and ponder. Write yourself a notebook. What are we going to get? What are we going to see printed out to the screen? Karen, what do you think?
I was just going to ask a question about the
Yeah,
difference
you can ask a
between
question.
P and
Yeah. P is just a shorthand. Essentially, it's saying like we can do puts as well. P is different. Is kind of like puts with a different format, but they are
got it.
generally interchangeable.
Cool. Okay, thank you.
Isabel?
So, can I answer the question?
Yeah,
Slash
you
ask
can
a question.
whatever
Okay.
we want. Yeah. Well, okay.
So
You
it's
can do
gonna
both.
it's gonna print out the names in the array with the capitalization. The question that I have is, do you need to put names outside that puts names? Do you need to put that outside of this iteration, or would that be inside of it?
So what we're doing here is that you're hypothesizing, prophesizing, one of those. That we have this names. We're going to go through and we are capitalizing it and we are printing out the collection. So this here is like we're printing out the collection. The idea, I think that what you're thinking is that, hey, this is going to capitalize all the names and we're going to print all of them out. Is that what you're saying?
Mm-hmm.
Let's take a look. All lowercase. And this
Yeah.
kind of, so why this happens is that each is what's called a non-destructive method. It does not modify the original collection at all. But let's say like you want it to like, let's put it this way, we don't necessarily want it so that, in general in Ruby, I am very loath to modify a collection. I don't want to change the names collection so it has all the names capitalized. I would much rather make a new collection with the names capitalized. The reason for that being is that like if you have a lot of things changing a collection and it breaks in a way you don't expect, how can you figure out where it went wrong if everything's kind of changing it, right? The original. So we kind of want to keep the original as it is, and we just make a new version of it and use that instead. So this is a pattern that we want to use. If we want to save the capitalization here, we need to create a place to save it. And we call this using an accumulator. So what I'm going to do, capitalized names equals empty array. And what I'm going to do is in here, and down here, we are going to capitalized and I'm going to run this. You see here the names are capitalized. So what's happening is that we have set up this names. This is our original collection. We are setting up what we call an accumulator. I also will sometimes use word collector because we're kind of collecting things into it. You can use whatever word you like. And that's going to be empty array because we want a collection of things. And for each name that we go through, we're going to take the name that we're currently on, that we're iterating on, capitalize that, and then put that into this collector. We do that for as many things as we have, and then when we print it out, we have capitalized names. We print out the collector, or we do whatever we have at the end. To kind of go back to what Karen said, I'm going to go and take away the P. I'm going to show you that this will look a little different. You can see here that when we use P, it's going to essentially do what's called like a developer view where it gives you a little more information. Like this P is sometimes preferred because you can see like, hey, I'm printing out a array of strings, whereas puts will just kind of list things out. Cool. So essentially P is like essentially a puts inspect. But that's not something you really need to know. Just need to know there's a difference between P and puts. And so to kind of go back to Joseph's question slash point question earlier, what happens when we, like in the instance where this happens, right? if I take this out and I just run it, like nothing happens, right? Because the return value is a thing, but we're not doing anything with it. Cool. Like each doesn't, to kind of reiterate, each is what we call a non-destructive method. It does not make any permanent changes to the item it is currently being called on. So we need to create this placeholder container to store a new collection. And again, it can be called the accumulator, the aggregator. I sometimes call it the collector because, like, you know, it collects it. Again, you could use a word that you like as long as it, you know, makes sense. Most of the time, 90% of the time when you are using each, you are going to use some kind of collector with each. Because you're going to do something each, but you know, like just doing each on its own, as we saw here, like this does nothing for us, like nothing printed out of the screen. When we use each to create a new collection, we need some kind of collector to kind of say what we want. In this case, it's capitalized names. Without this placeholder saving the thing, like all the work that you do inside this block, like it does not persist. It just goes kind of poof. Just it does the math or whatever, but it just does nothing here. Like again, without this accumulator, you'll not be able to access the information you want. Questions so far? V?
I asked it in Slack, but since you open up, is it because the reason for us to need a collector, is it because the method each always returns the original array the original collection unmodified, or is it because it returns as a string instead of a collection?
It doesn't return a string. Each always returns the original collection. So
Okay.
no matter what you do to each item in there, like it doesn't get saved anywhere. It doesn't persist. So if you are doing something to a collection using each, you need to have some sort of a collector.
Got it. Thanks.
Cool. Anything else? Awesome. Let's take a 5-minute break. We'll be back at 11:34. Recording. So we're essentially we just kind of did a thing where we're printing out all the stuff. But what we can also do is that we can, so essentially what we are doing here is that we're creating a new array that has the same number of items as the original collection. But what we can do is that we can also return only a subsection of a collection. We can still use each, right? And so we can grab this. And what we can do is, like, let's say if we wanted to get just the odd numbers out of this array, we can do that. We're going to set up our collector. It's going to be an empty array, and we're going to do numbers dot each do number. And what we're going to do here is if number dot odd numbers. I'm going to shovel in the number. And we're going to go ahead and just and I'm going to run this. And we can see that it has just created a collection of odd numbers. So what's happening here in this code is that it's going through, it's like, okay, 1 is 1 odd. Yes, shoveled into the thing. Goes back through. 2 is 2 odd. Nope, we do nothing. 3 and so forth. Yessie?
Yeah, so quick question. I noticed that both times we did the collector, it's been an empty array.
Yeah.
So does it always have to be an empty array, or is there a time where that wouldn't be the case?
The question I'd ask is like what I set up the collector as is yeah. is depending on what I want the final format to be. I want to end up with an array, so my collector is going to be an empty array. In the future, you may start doing these things with hashes. So you would then, set up with the collector as a hash. There are different ways. For simplicity's sake, in general, yeah, I would say most of the time you're just going to be working with either an array or a hash. And we haven't really gone too deep into hashes yet, so we're just going to stick to arrays right now. I would say 99% of the time you'd be working with either an array or a hash. Right, so
Okay.
that is why we picked this.
Okay, thank you.
Cool. Any other questions about getting this subset? Cool. And kind of to go further on Nancy's questions, let's show you a circumstance where we are not using an array. What if I wanted to get the sum of all of these things? I don't know what the number is. I'm just going to assume the math is going to be right. But what we do is total equals 0. And we're going to do numbers dot each do number. And we're going to do total plus equals number. And I actually don't know what the number this is. 55. That feels right. I'm gonna trust that it's right. And so I think the question here is why do we start with 0? And I think that we start with 0 because we're working with a number, and essentially 0 is empty. Is the kind of an integer equivalent to an empty array. It's nothing. It is empty, and so we can add things to it. So previously we were shoveling things in to an empty array. Here we're adding something to a number. And we have to have something. We have to create the accumulator and we have to set it because it's we need to add to something. And I think in math it's called the identity property. Is that when you add 0 to something, that you get itself, and that's why we pick 0 here. Cool. Any questions about narrowing things down or potentially alternative collectors? Karen?
So the plus equals symbol, can you tell me what's
Yeah.
going on with that?
Yeah, so Ruby has a lot of things in it, and the term for it is called syntactic sugar. It's like a shorthand for things. And so this plus equals is saying the same thing as total equals total plus number. These two lines are exactly the same. They're just, one is just shorthand for the other.
Okay, cool. Thank you.
Sydney?
So there was an example in one of the Ruby exercises where when the .new was called on that object, it was essentially calling .empty on that class. So does that class then equal an empty array?
I'm not sure exactly about which Ruby exercise you're talking about. If you could post that in the Code Help channel,
Okay.
in the thread, I think I need to see it.
Okay.
Yeah. Liam?
Just to clarify.
Oops, sorry, I hit the wrong button.
Oh, sorry.
No, that's my fault.
Just to clarify on an earlier question,
Yeah.
the reason you do total plus equals number would be because if you just did total plus number, it would do it for each one, but it wouldn't save it to the total.
Mhm.
Okay.
Yeah, but it's just it goes poof, right? The idea behind in computing in Ruby in general is after it does something, right? You have to tell it explicitly store somewhere, otherwise it goes poof, right? So the idea is I could do, let's just pretend I'm gonna a couple new lines down here. Oops. Nope, don't want to do that. let's just pretend the top bit of code works, right? If I do 1 plus 1, and if I ran this file, like, yeah, it would do 1 plus 1, but we're not doing anything with it. It doesn't get saved anywhere. So like, what was the point of it? You know, like kind of like that whole tree falls down the woods, no one's around here. Did it actually fall? Like, does it matter? Right. So like things don't matter unless you save it somewhere or you're displaying to the screen or putting it somewhere. Right. I think that's like, like you could have a method that does all this kind of stuff, but if you don't save it somewhere or return it, like essentially nothing happened. Very existential today. Good question. Cool. Other questions about enumerables, or actually each in particular? I'm going to take a sip of water to give you time to formulate questions because I'm thirsty. I'll also talk as I pour.
Oh.
Yeah.
So if you were to do run.each on an array, is there any way to get access to the index for the element that you're iterating over?
Yep. There is a method called each with index.
Okay.
Yep. And you can look that up.
All right. Thanks.
Ben?
Yeah, so you said how with the each do, you're not actually mutating the original array.
Yep.
Is there any like instance, kind of a two-part question, where there's a method that allows you to mutate the original array, and if there's a use for that, and like if you want to be actually modifying, you know, the original data instead of like, is there a use for that?
I mean, there's probably some use case somewhere, but again, like, don't recommend doing it.
Okay, cool.
The example I kind of, yeah. Well, you're going to learn more things. Each is just like, each is the gateway drug.
Right.
Each is that free razor with like the one disposable blade that they give you. And you got to buy the refills. But the idea is that, you know, because it is Halloween season, I get to use one of my favorite analogies. You have 3 17th century witches, mythical witches, making a potion in a cauldron. And each of them is throwing whatever ingredients in, whatever. It's cooking, it's boiling, they're stirring. Ooh, Hamlet. Hamlet had the witches, right? I think Hamlet had the witches. And like that potion, that cauldron explodes. Whose fault was it?
Oh, interesting. Okay, yeah.
You don't know because everyone was throwing, everything was modifying this collection of ingredients. So we're really not sure which one caused the reaction to cause it to explode. However, if witch A takes the cauldron, puts something in, hands it to witch B takes the cauldron, puts something in, and it explodes, whose fault is it?
Yeah, witch B.
It's witch B, right? So this is kind of like the reason why we want to, in general, like there's always going to be use cases where you have to modify a thing. We want, instead of modifying the original collection, we want to make a copy of it and use that instead.
Right, okay, makes sense.
Cool. Anything else about each? There are Ruby exercises around iteration and enumerables. So recommend doing those to get practice with each. But other than that, what I'm going to do is that I'm going to, as soon as I can move this window, I'm going to post some practice stuff for you to do. Cool. I'm going to let you go 15 minutes early. I would like you to work on this and spend some time working on this over the next 15 minutes while you're eating. I would say if you can, get it done before the end of the evening. Just some questions that will get you practicing during each. Cool. You're all set. We'll see you at 1. Goodbye.
Thank you.